Robots may be taking over factories. AI is rewriting how we work. But here's something even bigger. China has just unveiled the world's first all-frequency 6G chip, a device so powerful it can push wireless speeds beyond 100 gigabits per second. That's not just faster internet, it's a complete redefinition of how machines, people, and entire industries will connect. And the hidden truth is, this could change the global balance of power in technology forever. For years, we've heard whispers of 6G, the mythical successor to 5G, the network that would supposedly power holograms, autonomous drones, and even the Internet of Everything. But there was always a problem. No one had actually built a working chip that could handle the enormous spectrum needed for true 6G. Until now, Chinese researchers stunned the world by announcing that they had successfully developed a single chip capable of handling the entire range from 0.5 GHz all the way to 115 GHz. That's not just a small step beyond 5G, it's an engineering leap that breaks nearly every limitation scientists have struggled with for decades. But here's the catch. Building such a chip wasn't just about speed, it was about conquering physics itself. When 5G came out, it promised blazing fast speeds, but most of us never actually experienced that in daily life. The reason is fragmentation. 5G devices had to jump between different bands, low band for coverage, mid band for balance, and high band for speed, and each required different hardware modules. That meant higher costs, more power consumption, and devices that could never truly harness 5G's theoretical maximums. Now imagine scaling that problem to 6G. The spectrum widens massively from the familiar low gigahertz frequencies all the way up to the exotic terahertz range. That's like trying to build a car that can drive smoothly on both a village dirt road and a Formula One racetrack using the same engine. For years, engineers around the world tried and failed to unify these frequencies into one platform. The heat generated was too much, signal loss was unbearable, and the chips simply couldn't handle the transitions. But China's new design changes everything. The secret lies in photonic integration. Instead of relying purely on traditional silicon-based electronics, this chip uses light-based photonics to carry and process signals. Think of it this way. Traditional chips are like highways for cars. Every data packet is a car, and as traffic increases, the highways jam. But photons move at the speed of light. No traffic jams, no bottlenecks. By weaving photonic circuits directly into the chip, Chinese scientists managed to create a platform that doesn't just switch between frequencies, it flows seamlessly across them. The result is a single chip that can manage the entire spectrum of 6G with incredible efficiency, delivering real-world speeds that top 100 gigabits per second. That's fast enough to download a 2-hour 4K movie in under a second, or to live stream a fully immersive VR concert across continents without a single frame drop. To understand how disruptive this is, we need to zoom out. Telecom power has always been a game of geopolitics. In the 1980s, it was the US leading the 2G era. In the 2000s, Europe dominated 3G through companies like Nokia and Ericsson. Then came 4G, where American platforms like Apple, Google, and Facebook thrived. And with 5G, China's Huawei became the giant everyone was worried about. Now with 6G, the stakes are even higher, because whoever controls 6G infrastructure doesn't just control fast internet, they control the backbone of AI native wireless networks, the communication layer for autonomous vehicles, military drones, smart cities, and even future space communications. And here's the hidden truth. With this breakthrough, China has positioned itself years ahead of rivals like the US, Japan, and South Korea. With this chip, we're not just talking about faster internet, we're talking about the birth of AI native networks. Today's systems simply transmit data blindly, but with 6G, the network itself becomes intelligent. Processing happens in real time at the hardware level, allowing the system to self-optimize instantly. And that's only the beginning. Picture this. Instead of video calls, we could have holographic communication, life-sized holograms beamed straight into your living room, a CEO in Beijing appearing in real time inside a New York boardroom, not on a screen, but as a three-dimensional presence you can walk around and interact with. Then comes the age of autonomous everything, self-driving cars, delivery drones, robotic factories, all of them demand near zero latency to make split-second decisions. This chip drives latency down to the microsecond level, effectively erasing distance for machines that rely on instant reaction times. And perhaps the most futuristic of all, space and underwater communications. By spanning all frequencies, this chip could support connections in extreme environments where normal signals simply fail. From deep sea explorations to long distance space missions, the potential is nothing short of revolutionary. This breakthrough didn't happen in isolation. For decades, labs in the US and Europe tried to unify broad spectrum chips. DARPA funded projects on millimeter wave integration. European researchers experimented with terahertz band electronics, but every attempt ran into the same walls: high power consumption, overheating, or astronomical costs that made scaling impossible. In fact, one of the biggest challenges was something as simple as heat. When you try to process such wide frequencies, chips become miniature furnaces, melting themselves before they can run at full potential. China's photonic approach effectively sidesteps this by letting light do the heavy lifting, an approach Western labs had theorized about but never scaled successfully into a working product. That's why experts are calling this the Sputnik moment of 6G. Of course, it's not a done deal. While the lab results are impressive, real-world deployment comes with its own hurdles. First, building an ecosystem around the chip requires massive infrastructure upgrades. Towers, satellites, and consumer devices all need to adapt. Second, there are serious security concerns. A chip that controls all frequencies could be a dream for surveillance. Imagine governments being able to monitor or even control devices across every possible channel. And then there's the global reaction. Will Western countries adopt Chinese 6G hardware, knowing it could give Beijing deep influence over their networks? If China successfully commercializes this chip, the consequences will be massive. Telecom companies could rip out layers of redundant hardware, replacing them with single unified modules. Costs could drop, coverage could expand, and performance would skyrocket. But here's the wild part: entire industries built around current bottlenecks could vanish. Think about cloud providers charging premiums for low latency, or satellite internet companies spending billions on constellations. With all frequency 6G chips, those models may not survive. And beyond that, there's the dream of a truly connected planet where every device, from your toaster to a Mars rover, speaks the same wireless language, seamlessly, instantly, intelligently. This isn't just about faster movies or smoother Zoom calls, it's about who controls the nervous system of our digital future. The question is no longer if 6G will arrive, but who will own it. And as the race unfolds, one thing is clear: the world just entered a new era where light itself carries the future of connectivity. Don't forget to like, subscribe, and comment your thoughts below, because this story is only just beginning. And on Dezen, we'll be here to uncover every twist in this incredible technological race.